Yeah.
Okay. Okay.
And
Yeah.
then for the second presenter, the presentation materials will be uploaded by themselves. So are you confirmed, Lindy?
Yes, we are informed.
Right.
Robert knows.
Okay, thank you.
Okay.
So let's try keep track on time. So every presenters would have about the maximum 14 and 15 minutes, so that we can have a 30 minutes Q&A session.
부르면 나가면 되지. 얘들이 부르면. 홍수 보죠.
It's now 2 p.m. I think we can give a few more minutes for others to join. I think now we can get started. Okay, so distinguished guests, colleagues, ladies and gentlemen, are very welcome to join this webinar on integrated water management, digital solutions and governance. This is a third session of Korea ADB Urban Forum, co-organized by ADB and the Export-Import Bank of Korea, KEXIM. My name is Ok-Ju from the Urban Climate Change Resilience Trust Fund of ADB and the moderator of the session today. I'm so excited to be part of this session and hope the discussion today is productive and useful for all participants for mutual understanding and knowledge sharing. We have 4 presenters today, and their presentations will focus on water management and the use of digital technologies for more smart, efficient, resilient, sustainable, and inclusive water management. And for the sake of time, I will be very brief to introduce each of 4 presenters. And for more information about the presenters and the presenting organizations, please refer to the event flyer. Now let's move on to the first presenter, Mr. Sang-Young Park from K-Water. K-Water is a #1 state-run water company of Korea, and particularly the very pioneer of sustainable water resource management in Korea. It's now expanding its business to flagship smart city development project in Korea and Indonesia, specializing in smart water technology. And Dr. Sang-Young Park is a principal Global Cooperation Department of K-Water. Sang-Young?
Yes.
Now the floor is yours. Please go ahead.
Okay, thank you, Ok-Ju, for the very kind introduction. Good afternoon, everyone. My name is Sang-Young Park from Korea Water Resources Corporation. I think we need to share my presentation file. Okay. Okay. This afternoon, I want to talk about the development history of water resources in Korea and the smart water management, which is duplicable in the developing countries. Firstly, next please. Firstly, I'll deliver the overall introduction on the stage of development of Korea water resources. And secondly, smart water management mainly focus on the KCT global program of Korean government. And lastly, I'll share the smart technology for the Indonesian new capital city development. Next, please. The given condition of Korea water resources management is not favorable when it compared with the global average. We have a monsoon season and 2/3 of precipitation focuses on those formats. And about 70% of Korean peninsula is a hilly mountainous area, and thus it has significant variance in maximum and minimum discharge. Based on the water stress indicator by abstraction rate, Korea is a mid and high water stress country with China, India, and Italy. Next, please. This slide shows the situation of Korean War on 4 maps. The Korea War began on 25th June 1950 and ended on 27th July 1953. Right after the war, there were barely nothing left on Korean Peninsula as you imagine. Next, please. To overcome those difficulties and efficiently manage the limited water resources, we have applied various water policies, tools, and technologies. Since 1962, connecting the National Economic Development Plan, water policies has been implemented to secure sustainable water quantity, quality, ecosystem, and economy and social equity. Next, please. Korea's development in such a short period is a well-known success story. In this graph, the blue line stands for the gross national income since the year 1961. You can see the almost identical rising pattern of expanding national water supply network and developing water resources, which is in line with the economic development of Korea. This graph shows the evidence of water sector achievement of Korea. Next, please. The water supply coverage of Korea is 98% and sewerage coverage is 92% in the year 2012. The Chevi residence along the Cheonggyecheon stream became a symbolic location in modern river restoration. Next, please. This slide shows the water development path of Korea. Water is an essential resource in economic development, and the water resources development has harnessed the economic development of Korea. We have implemented and focuses on specific measures for water resources management reflecting the economic development. In the industrialization era, we developed the multi-purpose dam for water supply, flood protection, and hydropower generation. In 1980s, we developed a multi-regional water supply system. And then there was an environmental accident in 1991, which triggered sewer system enlargement. And in the year 2001, the eco-friendly development concept was introduced. And climate change mitigation measure has been an issue since 2009. Next, please. Back in the year 1960, the GDP per capita of Korea was $155. Korea was one of the poorest countries in the world. But we accomplished 100% sanitation coverage in the year 2000. In the process of water sector development in Korea, the overall strategy and vision came first, and the sector investment from various sources was sought after. Next, please. Now, we want to share the development history and experience and support the vision of smart city development. Recently, K-Water initiated the Busan Eco Delta Smart City, namely the future-proof city. The Busan Eco Delta Smart City as a national pilot city project started in year 2017, and now we are preparing the demonstration and pilot operation. The total area of EDC is 11.7 cubic kilometers for 76,000 people and 30,000 households. Next, please. The development concept of Eco Delta City is a waterfront eco city, global waterfront cultural city, and future logistic and service city. Next, please. I want to talk about a little more detail of those smart technology in the water sector in Busan Eco Delta City. The first one is precipitation monitoring and urban water related disaster response system, which is based on small size radar and sensor network. The second one is low impact development technology to recover the water cycle of an urban area. And particularly, and to improve the water quality of the river, we applied an eco-filtering system, and also the vertically connected water treatment plant and smart water management technology will be applied to the water supply system. And a water recycling system will also be equipped for wastewater treatment. Next, please. The Ministry of Land, Infrastructure and Transport promote the K-City network to create a to share the knowledge and experience of smart city development. Korean government initiated the K-City network global program to the entire world. Next, please. The Ministry of Land, Infrastructure and Transport promote the K-City network to create a Korean smart city through intergovernmental cooperation in overseas cities. In the year 2020, total 80 proposals were received and 12 projects were selected for the financial support to free FS or FS of smart city development. Next, please. I want to share the K-City network project for the Indonesian new capital city development. We provided technical assistance on the smart city basic plan, IWRM and smart water management, and smart urban transportation plan. Next, please. The vision of Indonesia for the new capital city is a global smart metropolis facilitating innovative growth and future life. The goal of new capital city development are establish integrated national identity and secure economic, environmental, and social sustainability, and also develop a smart city according to international standards. Next, please. This slide shows the ongoing master plan of IKN, Ibu Kota Negara, the new capital city of Indonesia. The Indonesia wanted to secure the national innovation growth engine through smart city development. Next, please. Now, from now on, I'll focus on the smart water technology we proposed in K-City network program. I will call it K-item. The first K-item is an integrated water resources management system, which is consists with an advanced sensor network, analysis model, and forecasting system. Next, please. The second K-item is intelligent water network operation based on the WaterNet system for the diagnosis, operation, and management of the water distribution system. ICT-based water operation system will monitor and control data on a real-time basis from the whole water supply system, ranging from the water sources to the tank. Next, please. K-item 3 is a low-impact development with green infrastructure, which slow down the urban runoff and spreading and soak the stormwater. Bioretention is considered with stormwater fund, free box filter, and stormwater wetland and infiltration basin. And there are many choices of LID technologies already in the market according to the local conditions and variety of water management, such as green roof and rain garden, water retention pavement, and infiltration trench and chamber. Next, please. K-item 4 is a decentralized water supply system with a vertically connected water treatment plant. The decentralized water supply system reduces the transport time and distance of treated water by installing the water treatment plant at the nearest place to their consumers. Next, please. By applying the vertically connected and modular type system, the required area of water treatment plant could be minimized. Next, please. Lastly, I added 2 more slides for the barrier and enablers for the implementation of smart water management. Based on the research and interview with stakeholders and experts, key barriers are such as lack of initial support and hesitation to replace traditional infrastructure and lack of policy incentive. On the other hand, there are key enablers to make it happen, such as political commitment and strong stakeholders engagement and training of people. Next, please. This is my last slide. Especially for the Indonesian situation, political issues and carrying capacity would be a risk for the implementation of smart water management. But there we have opportunity to work together. We have a long history of friendship between 2 countries and the proven competency and human resources of Korea. So this is my suggestion to proceed a collaboration further. Firstly, we need a working evidence reflecting the local needs and conditions by utilizing various funds such as eAsia and Knowledge Partnership Fund in ADB. And also, we need to take a long-term perspective in conjunction with the ongoing operation in the water sector. Through a close collaboration operation between home and field office, the implementation of smart water management will be a success story of collaboration. Thank you. 고맙습니다. Next, please.
Thank you so much, Sang-Myung, for the very informative and comprehensive presentation. It's so impressive to see such a range of smart water technologies can be systematically and an integral way applied into new cities development, into countries, Korea and Indonesia, which have much different context. So we hope we can further discuss all the other individual aspects of smart water technologies during the Q&A session. For the comments and the questions for Sang-Myung, please use the chat box already or speak directly by raising hands. As the 4 presentations today have some common background, I would like to suggest we go through all the presentations first and have the Q&A session at the later part of the webinar, unless there is a burning question or comment for Sang-Myung. All right, now we have 2 presentations from private smart water solution providers, Shindongha Electronics and Wiplet. I remember, in addition to K-Water, these two Korean companies also participated in ADB's e-marketplace on smart water technology in March this year. And I thank you so much for the continued engagement with ADB and the coming back for a new set of audience today. As for the program, let me invite first Shindongha Electronics, SDE. SDE is an electronic parts manufacturer equipped with a sufficient amount of technology facilities and processes. Mr. Sam Kim, a director of the overseas marketing, will present the company's smart metering and the control management solutions and how they are smart, functional, and easily applicable. Sam, now the floor is yours. Please go ahead.
Okay, thank you. And hello, ladies and gentlemen. First of all, it is great honors to meet any audience through online forum today. And I would like to express my gratitude to K-Water, who invited me as prisoner. My name is Sam Kim, who is in charge of exporting smart water meters from Shindongha Electronics in Korea. I only have 5 years working experience since 2016. The reason why I brought up my working period here is that smart water itself was not that common expression when I joined into the meter industry. However, nowadays in our modern life, you can see many home appliances using smart expression, like a TV and mobile, even the car. The smart water meters I'm going to introduce later also belongs to a tiny part of a smart city, even though it covers small part, but it's notable that the meter is starting point to enter into smart city. As people consider serious of a worldwide water shortage caused by these major regions here, so people have been thinking about how to save waters and use efficiently and wisely, regardless of these issues. Ironically, since WHO officially declared corona outbreak in 2021, corona, is one of the contagious disease that spread through human contact. For that reason, we have tried to make contact-free program as much as possible. However, the process of measuring meterage, monitoring, management, and billings are still necessary during corona period. There are growing interest in smart meters linked to wireless readings, and the demand and inquiry on contact-free product has been rapidly increased. As a result, Smart City project, which has been prolonged in Asia for the last 3 years, began to move forward faster than before. Thanks to cutting-edge technology development, the useful function has been fully equipped in the meters, which is high accuracy and the detection of leakage and the backflow and meterage manipulation. Here are 4 major strong points of smart water meters. The first would be accuracy in meterage. It has been advanced from ratio 100 to 200. Sooner or later, R400 above could be commercialized in future. And second and third, leakage and manipulation function are managed by software. And the final stage, the each management by IoT. The table is showing what kind of a function smart meter can provide it compared to mechanical one. I'm going to tell from the above one by one. Empty pipe alert, and next permanent data storage. There is no any single risk to lose data. And third, no one out. There is no any one out due to no moving parts in the meters. And reverse flow detect. Meterage is not counted in reverse flow and not counted backward on the register. The manipulation free, thanks to no moving parts inside the meters, is not be disturbed by wire play and magnetic attempt from outside. And leakage detect, it is monitored during particular time and detected. And no count airflow, there is no moving part can be affected by airflow. However, brass mechanical meters contains heavy metals such as lead, zinc, and formaldehyde, which may harm the human body. Our meter is an environment-friendly materials made from carbon monoxide. It's called the CO, which is main culprit of air pollution. It was certified as green product and certified by recognized international drinkable water certification body, such as FDA and ANSI, ANSI, and WRAS, which was well known in this industry. A platform that delivers data through wireless communication is called AMI. AMI is configured as 4 segments. The first segment, smart meter have a communication module, enables two-way communication by using Bluetooth, NB-IoT, and LoRa between consumers and water management companies. And secondly, communication network. And third, meter data management system. And lastly, an operating system. The AMI operating system provided variety of service, including remote inspector, demand management, and water consumption. The page is showing that the wire meters, the platform has been widely applied for last years. It is quite common system configuration for apartment. Advantages are stable data transmission and low power consumption compared to wireless. And disadvantage is high installation cost. We call it semi-auto program. The Bluetooth meter was first developed and commercialized by us in the world. As you can see, this model needs manpower when we need to get the data from the meters. And the rest of the process is done by communication network. There are three advantages. The first, very low cost and free data collection and transmission. The second, acceptable productivity. To the meter man, the numbers of meter readings in a day is much increased compared to manual reading. The last one, easy access to handheld device like a mobile and tablet PC. The disadvantages are it is vulnerable to read the data regardless of circumstance. If there is some obstacle between meters and device, reading distance can be disturbed or limited. Sometimes it is hard to read data from the meters according to environment where the meter is installed, like underground. Let me take some actual example we had applied in Korea. The all data was generated by our internet test. Since Bluetooth 5.0 version upgraded, the reading distance was quite extended and signal quality was improved as well. The signal passed through the wireless and brick wall to reach in height 15 stories, about 70 meters long. The sensitivity of a signal varied according to meter location. If your reading position is in the center of a building, A was positive, C was acceptable, B was not. And also, the readable distance varied according to the materials of obstacle. So as you can see, on open case, on open air, you could get 80, maximum reach 200. This is the most and best condition. It operates under licensed frequency band only based on LTE and should be used through network service provider. This platform has advantage that it can be installed in remote place and underground. And there is no any frequency interference due to using licensed frequency band. However, it has this advantage in cost. This system is useful for the place when well-equipped communication infrastructure. Otherwise, LoRa can be an excellent alternative. It operates under unlicensed frequency band and have advantage that a little power consumption are required and runs at low cost. Even consider of the communication distance is below 15 kilometers. However, it have this advantage that it required to build new network construction and is suitable to run at outdoors due to difficulties in passing through the wall. And there are some frequency interference happened. There are two kinds of mobile app I introduced here. The first one you are looking at is exclusively used for meterman. The main function is auto-scanning meterage from the meters installed and transmit data to server. The more functions are data download and uploading, and search function to find meter location, sending data and customer complaint to the management office. The advantage is anytime easy access to get meter information, and there is no extra communication cost required. The users can check all necessary meter information, including last and current meterage, and water sources, and monthly and daily use trend, and transmit direct complaint message to office, and alert detection, and even billing status. It manages leakage detection alert and communicate it by email and SMS. Accurate measurement of consumption and individual bills and payment and sources of waters, use of water like drinking. Utility waters can be segregated. Tank water management. The platform provides comprehensive reporting on individual meters and standard graphic views such as leakage, reverse flow, battery status, and pending bills. Storage dashboard. The platform comprehensive reporting on storage and supply synopsis for the property managers, including supply volume source and storage volume in each tank. The photo is showing that we had field test in Malaysia. From the left is a Bluetooth, is installed in apartment, and the middle position of the screen is a gated house. It's very much open space and operated by LoRa. And the last one is a terrace house, which is same as LoRa as well. And this is commissioning in different countries. The first one would be apartment in Korea, even small space, it could work very well, and India and Vietnam. You may see that the first photos in apartment in Bluetooth, the difference is that our meters can be installed in vertical position, not from the horizontal. You can see the star mark. This is, we are currently either field testing and the commissioning in the Southeast Asia. So you may take a look at, and if you have any question on this, so we can take a look at it later on. Thank you so much.
Thank you so much, Sam, for the very informative and impressive presentation. Accessing real-time data from key assets, customers, and the citizens is increasingly feasible and important in developing cities. A few keywords that I picked up from the presentation include Meterman, application, mobile app applications, and the different ICT environment which enable your technology available and accessible, and also easy interface with the client and the service providers. Hopefully we can explore further the smartness of your solutions during Q&A session. And now let me turn to WIPLAT. The company name WIPLAT stands for Water Intelligent Platform, right?
Yeah, you're right.
Yes, the company is a startup supported by K-Water and the Korean government, and Mr. Sang-Hoon Cha, founder and the CEO of the company, will present intelligent water leakage management system that even non-professionals can easily use to detect water leaks. So Mr. Sang-Hoon Cha, you have a 15 minutes maximum for your presentation, and now the floor is yours.
Okay, thank you for having me at this wonderful conference. Let me start my presentation. And with IoT AI cloud technology, we solve the water leakage problem around the world. I'm Sang-Hoon Cha, CEO of Webplay. Next. We have very long pipeline even in South Korea, which can rotate 5.5 tons of the earth. For detecting the water leak point of the long pipeline, we still rely on the experience of the professional water leak detectors. Next. But some countries without professional water leak detectors, that they have to stop the supplying the clean water when they face the very severe drought caused by the climate change. Next. Sometimes water leakage threatens our lives in the city. Next. And we waste about 40 billion US dollar every year in the world because of water leakage. Next. Therefore, the Webplay was founded as a K-Water in-house venture to address the global water leak issues. Next. Actually, for a successful water leakage management, we need the system engineering devices. It means that it requires very long time and very huge finance. So some developing countries which have no huge finance and the time, so it is very hard for them to manage the water leakage successfully. Next. Therefore, we came out the solution to solve the water leak problem in the world. As a very first step, we integrated 3 or 4 existing software into the one cloud-based software. And the second, we replaced the high-cost expert with the AI and the big data analysis technology. And then we call this intelligent water leakage platform. And we also developed IoT device to connect this platform with the clients around the world. Next. This is a Nello. Nello consists of a Sony M1, M2 hardware and a Nello software. Next. Let me show you how things got changed when you use a Nello system. Can you play the video? The client collects water leak sound with the Sony M1 smartphone and they send the sound data to the cloud server. And our AI model applied in the cloud server analyze the sound data and pinpoint the location of a water leak. So it means if you have any country and any place, if you have a smartphone on your hand, now it is very easy to find out the location of a water leak. Next. So our technology is focusing on replacing the professional water leak detectors with the non-professional people and the data analysis. Next. This technology has been verified in many places by using a K-Water testbed program in 2020. Next. And we started to sell our systems since February of this year. And now 9 local water service authorities in South Korea are using Nello. Next. If the developing countries save the water from the water leak reductions, they can get a very huge economic benefit because they can save cost for construction and human resource, maintenance management, and the electric power consumption. Next. Therefore, as for the overseas business, we normally do performance-based project with cooperate with the local partners with the different level. Level 1 is target goal of a 30% reduction of a minimum night flow. Level 2 is 50% reduction of a minimum night flow. Next. Minimum night flow is the water flow from 2 a.m. to 4 a.m. normally. And from my experience, about 60 or 70% of minimum night flow is a real water loss. Next. So we focusing on the target project target, the real water loss in terms of NRW. Next. Actually, for the goal of level 1, I think a narrow system is enough for achieving the goal of level 1. Next. For achieving the goal of level 2, we need the DMA management system. So DMA makes it possible to save time for water leak detection and to control water pressure. Next. Okay, telling you a little bit more about the technology of the water leakage management. Actually, advanced water leakage management requires 3 types of technology. One is a detection, second is reduction, and third is prevention. Next. Water leak detection is normally approached from shape to line to point. Next. So minimum night flow monitoring of DMA is required for narrowing the water leak suspicious area. Next. And then once we narrow the water leak suspicious that area, which is called the DMA or block, and then we need water leak sound analysis technology to pinpoint the location of a water leak. This is a general process for pinpointing the water leak location. At the first steps, we have the local steps to collect water leak sound from the valve or water meter, and then send the collected sound data to the cloud server. And our AI model analyzes the collected data and shows the suspicious area. And then we send the engineers to the suspicious the spot, and then collect water leak sound additionally from the ground for pinpointing the location of the water leak. Next. And the second technology is the water for reducing the water leak. We need to control the water pressure in DMA. Next. And for preventing the water leak, we have to control the water hammering pressure. So our narrow system helps the customer to measure water hammering pressure and manage the water hammering pressure. Next. A little bit deeply explained about the water leak sound analysis. Actually, water leak sound disappeared in proportion to the sound absorption rate of a pipe. When it comes to plastic pipe, the water leak sound does not go too far, only 20 or 30 meters. Next. This is why we developed the HandyAir type, the smart IoT device for detecting the water leak, because you have to inspect water leak every 20 or 30 meters on non-metallic pipe. Actually, from my experience, about 70 or 80% of the water pipe is a non-metallic water pipe. Next. So now in South Korea, only local people has been hired for collecting water leak sound. Actually, one person normally collects 100 or 120 water leak sound a day. Next. So all Korean clients are using 1-year subscription service of Nelo right now. Next. This is just a simulation. If in the case of 15,000 houses, a very small town. So if we save a 30% minimum night flow reduction, we can save about $342,000 a year. Next. It's a level 2 simulation. Next. Actually, as for the overseas business, we prefer cooperating with the local partner who are building a joint venture for performance-based project. Next. This is work scope of each party. Next. Now we we are doing a 5 months pre-POC. So that five months pre-POC will be solved for technical verification of NELOS before we sign a contract. Next. Next, please. Okay, this is our goal. Our ultimate goal is to bridge water service gap between developing and the developed country using by developing the disruptive technology. Next. Okay, thank you.
Thank you so much, Sang-hoon, for the very informative and impressive presentation. And also, I see you have wonderfully reflected some questions and the comments from the previous ADB e-marketplace by giving us not only the overview of the technical features of your technology, but also very articulated cost estimate of your service chain covering Sonic 1 and 2, software, NELO program, and the trainings for maintenance and operation. Thank you so much, and I hope we can further discuss this cost effectiveness of your product during Q&A session.
Okay, thank you.
Thank you. So I am a little bit cautious about time, but we are on track. And now would like to turn to Mr. Dong-hoon Cha, Director of Seoul Water, also called Arisu, which provide water supply, tap water to 10 million Seoul citizens. As we know, the city of Seoul is highly densely populated and the largest city of Korea, and it has the most complicated water supply system. So he is going to present water network management or metropolitan city. Mr. Dong-hoon Cha, over to you. Please go ahead.
Good afternoon. I'm Dong-hoon Cha from Seoul Water Institute of Seoul Water. First of all, it is my great honor to have an opportunity of introducing the experience of Seoul's tap water, Arisu, at Korea ADB Urban Development Forum. Today, I would like to explain how Seoul metropolitan government manage the water pipe networks. Next, please. This slide shows the outline of today's presentation. Next. This slide explains Seoul Water with several figures. Seoul Water has supplied 3.1 million cubic meters of tap water to 9.9 Seoul citizens a day on average. The length of pipe network is 13,432 kilometers, which is longer than the linear distance from Seoul to New York. Today's presentation theme is how to manage this long pipe. Next, please. The Ministry of Environment in South Korea has conducted various surveys on tap water by 3 years. This slide shows the result of the status of drinking water published in 2017. The rate of drinking tap water and of not drinking tap water were 49% and 51% respectively. Possibility of faulty in a water tank or an aged water pipe and due to foreign substance and odor takes 51% and 70% separately as a reason why people are reluctant to drink tap water. Moreover, since there was a nationwide water quality accident in pipe network around 3 years ago, citizens' concerns in waterworks pipe network is growing. Next. To this end, I would like to elaborate on improvement of the pipe network's infrastructure and maintenance of pipe network and strength communication with citizens for better water pipe network management in Seoul. Next. The pipes built before 1983 easily oxidized into rust. So we have continuously replaced the existing pipes into corrosion resistance pipes from 1984 to now. The replacement into non-corrosive pipes have meaningfully contributed to improve water quality in the pipe networks by significantly reducing rust water. Next, this shows the status of waterworks pipe network by years. The pipe network used more than 31 years amounted to about 3,000 kilometers, taking 21.8% of the whole pipe. Next. This is the status of waterworks pipes by pipe types in Seoul. There are only 74 kilometers with cast iron pipe and galvanized steel pipe, which are corrosive. Next, please. In the past, around 40 years ago, installation and linking water pipe were important to supply water. And then the focus moved on to the prevention of the corrosion in the pipes. Now, the coated lining inside the pipe offers 35 years old, in which tap water flows, is the top priority for management. Ductile cast iron pipe, which are strong against corrosion, have been built, but in the case of pipe used more than 35 years, the materials coated on the surface of the inside pipes have been lifted off due to aging. Accordingly, we set a section 455 kilometers to be prioritized to repair, and it is scheduled to carry out preemptive maintenance, such as pipe flushing, rehabilitation, and replacement in line with result of pipe network analysis. Next. Aged pipe maintenance project has brought not only water quality improvement, but also economic effect with reduced leakage. Of course, Seoul metropolitan government has conducted various projects like water pressure adjustment, block system introduction, in addition to the aged pipe maintenance project to reduce leakage. As a result, the revenue water rate, which was 59.4% in the 1989, has reached 95.5% in 2020. By reducing the production volume of tap water in consideration of leakage, the Seoul Water has saved the production cost amount to $3 million and leakage recovery cost, as well as sewage treatment cost amounted to $7.5 million. Next, please. The inside condition of pipe are highly influenced by topography of the site and operational conditions. So it is needed to accumulate enough information on the inside condition of the pipe. However, water pipe are underground and tap water has flown in the pipe network continuously. So figuring out the inside condition is one of the difficult tasks. By continuously accumulating data with the zoning system of pipe network, it is planned to do preemptive maintenance, such as flushing, rehabilitation, and replacement in line with the water pipe conditions. Next. Citizens do not prefer the odor of residual chlorine from the tap water. Residual chlorine level has gradually reduced during the tap water supplying process to household after being injected. To satisfy the target level of residual chlorine for household, which is the farthest from the water treatment plant, high level of chlorine was injected at water treatment plant, which is the first spot for chlorine injection. So residents near the water treatment plant smell strong odor of of the residual chlorine. To resolve this issue, Seoul Water has installed the additional chlorine injection facility on the route of tap water supply process. Next. First of all, let me apologize. There is an error in the legend in the upper left corner. The description for the pink and yellow areas are reversed. The pink area is where residual chlorine shows the relatively high level, whereas yellow area shows 0.1 to 0.14 milligram per liter of residual chlorine. In addition to current 11 re-injection spots, it is scheduled to add 10 more spots to stably equalized residual chlorine level. Next. Moreover, to prevent the accumulation of pollutant particles and creation of the scale inside the pipe flushing will be strengthened further. Till last year, Seoul Water only flushed the main distribution pipe, but since this year, it is planned to flush the whole pipes by 5 to 10 years. Next. Applicable technology for pipe flushing are varied in line with the pipe diameter. In other words, Seoul Water has adopted various applicable technology for the pipe diameter with less than 350 millimeter and more than 400 millimeter. As of now, for the pipe within 350 millimeter, pipe flushing by speedy water and pipe flushing by mixing air and water have been used. For a pipe with more than 400 millimeter, we are looking for a proper method. In this regard, Seoul Water has hosted the pipe network flushing technology contest to explore excellent technology from private company. Next. At this contest, 6 companies had joined and applicability was evaluated in the field. It was a constructive opportunity to understand the status of various technologies developed by private company and technological applicability in line with site characteristic. If we are trying to find a technological solution for a new issue, this approach will be very useful. Next, please. Yeah, to provide accurate information on water quality in the pipe network for citizens, Seoul Water has expanding the monitoring spot to 424 branches. Moreover, citizens could check real-time information on turbidity, residual chlorine, pH, and supply routes via RSU app. Next. Lastly, I would like to talk about the importance of data management in water pipe network management. One of the reasons why pipe network management is difficult is that it is hard to figuring out underground condition, and working condition is not favorable, like small underground working space and short time of water outage. To resolve this issue, utilize digital technology and managing precise data must. To do so, it is required to consider software aspects in addition to facility expansion when a developing country plan to enlarge waterworks facility. Next. Yeah, this concludes my presentation. Yeah, if you have any questions, please email me. Thank you.
Thank you so much, Dong-Hoon Cha, Director, Seoul Water. Yes, I think it's extremely informative and impressive presentation on the continued effort of the city to provide a safe and high quality water to 10 million populations. Yes, definitely, 15 minutes is too short. I pick up a few keywords from the presentation, like a constant physical rehabilitation of pipe network and the GIS monitoring system, and also citizen services using different software and the mobile applications, etc. And also, you didn't emphasize too much, but another big learning to me from your presentation is, surprisingly, 100% of water for 10 million populations comes from only Han River. So as we know, Korea is one of the most vulnerable countries to climate change. And I'm wondering if Seoul City has which kind of resilience measures to cope with the challenges, potential challenges like drought, which will affect the water balance and the water availability of Han River Basin. So hope this climate resilience of the city's water system can be further discussed. For example, which kind of smart technologies can be used now, being used for increasing resilience of the water system. Yeah, if it can be further discussed during this session, although we have only 13 minutes remaining and a very tight schedule. So thank you so much, all the four presenters. I think now we can move on to the Q&A session. So I'd like to invite all the four presenters to turn on your video, and yeah, and also to help the audience understanding who is who, and for their comments and the questions. So to open the Q&A, maybe I could have one question to you presenters. So for example, in fact, this question is from the previous session, so yesterday. So you and your institutions are working in different cities in developing countries. So what, based on your own experience, what are the main challenges or even opportunities working with the cities in developing Asian countries? Of course, every city and everyone want to go green and smart, but for many, smarter technologies are still new. So, for the perspective of developing cities in Asia, where and how to start. So please, anyone, among speakers, if you want to respond, please give your insightful tips. So anyone want to respond?
Okay.
Yes, please.
Yeah, actually, I have a couple of experience about doing a kind of a test bed in Vietnam and the Philippines and Malaysia. And while I worked in the K-Water, actually, even though I'm CEO of Whipplet, the in-house K-Water in-house startups, but I have worked in the K-Water for 23 years before I founded the Whipplet last year. When I did that kind of a pilot project in Vietnam and Malaysia, actually is the customized smart technology is very important. Even though those technologies, we knew that smart technology in South Korea. South Korea, we are living in the countries of 30,000 GDP. The developed countries. So we're using a smart technology which is customized to that developed country. But if the Vietnam and Indonesia and other countries that they are very low income society. So income about 3,000 or 4,000 in case of Vietnam, the GDP. So before we apply the smart technology to those the developed or underdeveloped countries, so we have to emphasize on the customizing the smart technology to apply the technology to that kind of developing countries. This is what I saw, the why I'm doing the pilot projects in the developing countries.
Thank you so much, Sang-Hoon, for sharing your lessons and experience. So yes, of course, the applicability and the tailored approach of smart application is really important. I think a smarter technology compared to any other hard infrastructure and services is good for adaptation to local need and the local situation. Thank you so much. And now in the chat box, I see very good and very long comment as questions from Terry. So Terry is the Senior Urban Development Specialist of SDCC. So I would like to invite Terry to speak. So to address questions directly to presenters instead of me reading the questions. So Terry, please come in.
Thank you, okay, John, and then thanks for the great, very insightful presentation of these four individuals in presenters. I'm most interested for the intelligent water water management. So I'm very delightful to see you have expand the application of the smart meter solution outside Korea, in the Vietnam and India. So you have present a little bit favored on the field testing. So any field result can be shared, and as already mentioned by one of the presenter, Mr. Chang, that it is you need to consider the country context. So I want to know how you can convince the lower income country like Vietnam and India, their utilities to invest this type of the technology. And what is the favorable modality for cooperation, like you have mentioned performance-based contract? And I think that in fact, I see your business model on a subscription is very, I would say, very user friendly. And I already see some other player. I cannot name them for you, for commercial secret. But it's a similar approach. So I want to know: is it when you prepare this kind of the intelligent water leakage management? Is this kind of the more user-friendly pricing strategy will have more easy to cooperate? And also, what's your actual experience to using the PBC performance-based contract in the field outside of the Korea? Thank you.
So thank you, Terry. So your question is to Sang-Young, K-Water? Or you also mentioned the performance-based contract?
Yes, I think first question is for the K-Water. Second is the how to say?
Reflect.
Reflect. Yes, the start is really nice. I want to know their pricing strategy. Is this come from their experience? Because I found that it's in a similar competitor. So I just very curious on this kind of new thinking of the pricing strategy. Is this more user-friendly and easy to be affordable by the client? Thank you.
Okay, thank you so much. So Sang-Young, please come in to respond to the first question.
Okay, thank you, Terry. Thanks for the question. Well, when we try to apply the smart water technology to our developing countries, many people refer to that where we are not ready, especially for the ICT infrastructure. Those ICT infrastructure is quite the gap is quite big between Korea and my country, so we are not ready, something like that. But in the case, I told them, right, okay, this ICT-based smart water management system, it can dramatically reduce your water authority budget, because when you fully renovate those pipe systems in your catchment, in your service coverage, it will cost a lot. But by applying this ICT-based sensor network and district metered area and some the leaky detection device, we can dramatically reduce those non-revenue water in your water authority. It is the one good point to adopt this smart water technology. And also for the ICT infrastructure development, we can see in our developed members country, everyone holding mobile phone in their hands. So I think those general exposure to this ICT technology already changed many things in our developing countries. Thank you.
Thank you so much, Sang-Young. I think we played Sang-Won-Cha, Mr. Sang-Won-Cha. So do you want to respond to second question from Terry?
Okay, thank you for your question. Regarding the performance-based contract in developing countries such as Vietnam and especially in India, it is very important to overcome the obstacle of the time and the space and the people. It means in the past, when we give a kind of capacity building or technical transfer to the developing countries, we always have to send the high cost the engineers to the country, and we also trying to apply some kind of a very high cost smart devices and the smart technology directly to the country. So in that case, the performance-based contracts cannot be proceeded because of the cost of the project. In case of the NRW management, when the performance-based contract is like when you invest the cost first, and then we recover the invest cost from the benefit of the project. In that case, in case of South Korea, the unit production cost of water is $1 per cubic meter, but in other developing countries, their unit production cost is only what 30 cents or 40 cents per cubic meter. That means the benefit, economic benefits, is different. So we have to adapt the technology to achieve the economic benefit that developing countries can accept. So that I think that is the point. That is the why we are focusing on the smartphone-based technology, because if we have the smartphone-based IoT devices such as the Sony M1, we do not have to send a person to the developing country. We only send the Sony M1 via airplane, and we give the online training to the local partners, local people, and they do kind of engineering activities on their own. So we can save the cost for human resource and the cost for the kind of a smartphone device, smart devices. That is the key point we are focusing as a technology for achieving the goal of a performance-based country. Yeah.
Thank you so much, Sang-Won-Cha. So I see in the chat box a very active discussion between Terry and Sang-Won is ongoing. So I think we can continue, even offline after this session. Waiting for other participants to provide their comments or lessons So I would like to have one question to Shin Dong-ah, so Mr. Sam Kim. And especially during your presentation, you have mentioned, how the technology is applicable to different ICT environment. For example, wired communication, and also narrowband IoT, and also Bluetooth. That you emphasize the Bluetooth, using the Bluetooth was the company's own invention. So listening to your presentation, I was wondering, because in many different countries, in developing cities, in developing countries, ICT environment is very unstable and very weak. So I'm just wondering if there is any way for those cities to benefit from your smart water technologies.
Thank you for your question. As you said, underdeveloped country, they are not well organized, and they are not well equipped with wireless network infrastructure yet. But I would say that this the region I recommended Bluetooth. Bluetooth is one of the things without any well-equipped infrastructure. It just works by mobile itself. So, for example, instead of visual checking, or the meterman can walk into the home, instead of it, they can walk through or pass through on the residential area. It can be detected, and they can send the data from the phone to the network provider. This is very much the same thing as just the call mobile. So that concept is adapted to Bluetooth smart metering solution. So this is more economic way for underdeveloped countries to observe the low cost. So this is the things we approach to the local government, especially in India, in Vietnam. They are suffer from the cost-wise. And we also suggested, and we are very much wide open opportunity to transfer technology. That's the things we encourage them to go for more forward. So I would say that the low cost and the localization, including factory transplant, or to maximize to use the local product. These two factors encourage the local peoples to do it.
Okay, thank you so much, Sam, for the very concise but excellent response. So I am looking at the chat box and a list of participants, attendees. So do you have any other questions or comments? Please don't hesitate to provide your input. And I see the list of attendees. There are many ADB colleagues and also participants from Korea. So anyone who want to share the comments or questions, please just raise a hand or use the chat box. Yeah. I think Hyungyul from ADB, he raised the hands. Hyungyul, please go ahead.
Yeah. Hello, everybody. Very nice to meet you. Since it seems that there's no any questions or comments at this moment, so I just intervene. And I'm a fund manager of the eAsia Knowledge Partnership Fund, EAKPF. We organized this forum with ADB Urban Sector together. And eAsia Fund is a trust fund in ADB established by the Korean government. And we are supporting about $15 to $20 million every year for ADB TA projects. And the purpose of our trust fund is to promote use of digital technologies in ADB projects, in particular through cooperation with Korean businesses or Korean institutions. So if you are interested in those areas, I mean, using the digital technologies through cooperation with Korean businesses or institutions, then eAsia Fund is the right place. You can explore funding possibilities. Yeah, it was a kind of advertisement. Thank you very much.
Thank you so much, Lee Hyung-yeol, for using this opportunity to promote your fund. So I think we can, contact him again, to get further details. So anyone else who have any questions? I see only Hyung-yeol who raised their hands. So among ADB colleagues, I see, for example, Mr. Sok Yong-yoon, and also, other many colleagues from CWUW, Jong-ho, and the other colleagues from Pakistan, Shaukat, and I saw Saurabh from India. So any other questions and comments? And for the, yes.
No, I think there are many
Lara.
questions at your box.
Yeah, I think Lara raised her hands. Lara, please come in.
I had a question in the chat box, but I understand it's difficult. And since no one else has, I just thought I'll ask a question. So one burning question I have, especially to Arisu and people from Seoul Water, is that what measures have you taken to manage the demand side? I mean, we've managed the supply with all this great technology, but how are you managing human demand in terms of raising awareness on consumption aspects? So you've got the whole dashboard for the quality aspects, but what about the consumption aspects? And do you do any awareness campaigns that accompany your very smart solutions? Thank you.
Thank you, Lara. So this question is to Mr. Dong-Won Cha, Seoul Water. So from Seoul City, I'm sure that Seoul City has awareness program to reduce the water consumption, and not only just try to provide a high quality water, but avoid the, how can I say, wasteful use of tap water and any other purpose. So I think Dong-Won Cha is not, I cannot see him here. So I think it's good to give him a few more minutes to prepare the response. I missed I missed the question, one question from Stefan. Yes, within the low ICT environment, off-site metering, OMR, using RF, such as mentioned, the Bluetooth may be a good solution. It also provides a job for more or many people. Yeah, so I think on that aspect, maybe someone replied, do you want to come in to add any additional point? Yes, please, Sam, go ahead.
Okay, let me tell you about our past experience, which occurred in India and Vietnam, especially for Bluetooth point-wise. Yes, that is the right point. The peoples are in underdeveloping countries, especially to the local government. They are very much scared of the reduce of the manpowers, which is that very much close related to election. So they are looking for very good slogan in the government, which is that they already start what they are looking for, smart part of a smart industry. In other hand, they have to reduce the manpowers. So they try to get two things in one hand. So the Bluetooth is, in political wise, it is very much good answers. And the way over to people overseas, the manpowers, That's another solution as well. And on top of that, the underdeveloped country, the labor cost is very low. Is that not much impact to the total cost? So they were very much happy with it. They can get everything in one hand, just a step back, get a little bit cost increase compared to others, NB-IoT and LoRa stuff. That's the way, one of the successful key to enter into the market.
Thank you so much, Sam. And Sang-hoon from Replay, do you want to add any other aspect of the available technologies in developing cities?
Actually, I fully agree with Mr. Sam. Yeah, and when it comes to developing countries, we have to focus on the technology to save the cost and to save the cost for smart device and the cost for engineers from outside from the developed country. So this is a very good first step to use this RF or Bluetooth technology, because if you use Bluetooth technology, that means you can use a smartphone. But all of the underdeveloped developing countries, most of the people are using smartphone. So smartphone can be a very good data gateway from the sensor to the server. So if you use a smartphone, you don't have to use any type of a gateway or stationary IT devices. So I think it's very good step to use the Bluetooth or that RF type of technology in case as for the underdeveloped or developing countries. Yeah.
Okay, thank you so much, Sang-hoon. So, I realized again that the mobile phone is really key for a smarter era. Now I see Mr. Dong-hoon Cha is there, from Seoul Water. So, Dong-hoon Cha, you have two questions, in fact. So the first question from Lara about the awareness raising program on water consumption by your institution. And the second question was from me about the climate resilience aspect of your water system. And especially, yes, I emphasized I had the opportunity to discuss how Seoul City is vulnerable to climate change impact, like flooding. And also today wanted to mention also, the risk of a drought. So if you have any climate resilience measures that you want to present or introduce to the audience, please do. So Sang-hoon, Dong-hoon, sorry, over to you. Please come in.
예, 저기 한강은 다행히도 큰 유역을 가지고 있어서 수량에 있어서 큰 문제는 현재까지는 없습니다.
We'll
sorry,
talk
so-
through the
okay.
translator.
Okay, please go ahead.
Yes. So the Han River actually has a very large basin. So in terms of the demand management, we do believe that the size of the Han River actually solves the basic issue of the I'm
The
sorry,
water smell.
the basic
Water availability, water resource availability.
yes, the water resource availability issue.
Okay, great to
그래서
hear.
물 사용량을 줄이기 위한 노력, 그렇지만 이제 기후 변화나 가뭄에 대한 우려가 증가되고 있어서 물 사용량을 줄이기 위한 노력들을 해 나가고 있습니다.
But because of the impacts of the climate change, yes, we are applying many different measures to raise awareness of the water usage management.
그래서 그 방법으로 이제 물 사용량을 줄이기 위한 수요 관리라든지 누수를 줄이기 위한 활동, 또 빗물 이용, 물 재이용을 확산하는 정책들을 이제 추진해 나가고 있습니다.
So we have been implementing policies, including first to manage the demand and manage the leakage and promote the use of the rainwater and promote the use of reuse of the water.
두 번째 이제 물 사용에 대한 인식 제고와 관련해서는 이제 저희가 수돗물을 사용하는 것이 이제 일반 샘물이나 이런 것들에 비해서 보다 친환경적이라는 부분들을 많이 강조하고 있습니다.
In terms of the promoting the awareness, we have been promoting that the use of tap water is very eco-friendly and safe way to consume water.
예, 특히 이제 폐플라스틱을 사용량을 줄이자고 하는 그런 인식들이 많고요. 또 이제 환경 에너지 사용이나 이런 에너지 사용량을 줄이려고 하는 인식들이 높아지고 있기 때문에 그런 부분에 있어서 저희가 수돗물의 환경적 가치에 대해서 많이 이야기를 하고 있습니다.
So we are trying to promote the value of the tap water. So in order to communicate to the people that we need to reduce the use of the plastic bottles, and at the same time reduce the energy used.
예, 그래서 이런 것을 시민 단체들하고 캠페인도 하고요. 또 저희 지금 한국에서는 이제 지역화 교과서라 해서 서울 지역에서 쓰고 있는 그 초등학생들의 교과서 내용에도 어떤 수돗물의 물의 가치, 또 물 절약의 가치, 수돗물의 과정 이런 것들에 대한 것들을 교육청과 협력해서 자료도 제공하고 있습니다.
So we have been communicating through the civil groups, and we have been campaigning that the value of the tap water, and at the same time we have been providing materials so that the value of the water is educated to the children of our people. So in the schools they are learning that the value of the tap water and the need to save the water.
Okay, thank you so much, Dong-hoon. So very nice and excellent, response. So I think we are almost, run out of our time, and then I'm sure that you, participants have more questions and the comments to share. So if you need the contact information of presenters, I think presenters are happy to provide. And then also the final presentation document can be shared together with the recording of this webinar. So before we close the session, I want to invite again all presenters for their very short concluding remark, maybe following the order of presentation. So Mr. Sang Yong-bak, Dr. Sang Yong-bak, do you want to start?
네, 고맙습니다. Thanks thanks for the ADB and thanks for the very nice place for exchange our opinion inside in spirit and water sector for smart water management. I think we are solution provider, but we were problem hunters. So we are ready to share our unique experience in water sector to our development partners. Thank you.
Thank you so much. And then Mr. Sam Kim, for your concluding.
Okay. I'm so sorry. I think it's the other things. So, okay. Thank you so much for precious time to extended us, and hopefully we like to have a better position or better opportunity other than last year. So even though in the Corona situation, I hopefully people some in good condition and doing well. So on top of this issue, so you don't have any attendant, you don't need to any afraid of the cost-wise. We can provide it, and we are ready to go for more economic and the productive way how to work it out. So thank you so much once again. And if you have any question, please feel free to contact us anytime. Thank you so much.
Thank you so much. And then Mr. Sang-won Cha from Reflect, your concluding
Okay.
remarks.
Okay, thank you again for having me at this wonderful event. I'm looking forward to the having opportunity to work with the ADB in the future. Yeah, and I really hope to be a help for solving kind of many social problems of the developing or developing countries through this kind of the event and the disruptive technology. Thank you so much.
Thank you so much. And then Mr. Dongwon Cha from Seoul Water, please, your concluding remarks.
Yeah, thank you for your invitation. I hope this opportunity will continue in the future. Next time, I hope that Corona situation will be over so that we can have more in-depth discussion face to face. Yeah, thank you. Yeah.
Okay, thank you so much. And many thanks again to 4 presenters and also colleagues from ADB and the Korean institutions and the companies for your time. And a special thanks to Haeshin and the Exim Quaxim Export and Import Bank of Korea for the organization of this meaningful event. Please stay with us tomorrow at the same time for the Smart Energy session and a Smart Transportation session on Friday. Thank you so much and wish you a very nice rest of the day. Bye-bye.
네, 고맙습니다. 수고하셨습니다.
Thank you.
Thank you, everybody.
Thank you. Thank you, Lindy and the Thomas, Mayani, and the others. Thank you, Terry, of course. Thank you.
Thank you.